How's it going, everyone? Welcome to another video, and in today's we're going to talk about is the advanced Redux bot, a important concept which is immutability data. So why this is important and why this is matter. So since we are now dive deep into what is the problem that Redux actually solve, especially RTKey, what is the problem that RTKey is actually solving, or what is the solution that they provide, and as well as to the particular problem. Here we are going to see a quick recap of this course and how do we get into that point. So Steve Kinney is the head front-end engineer at Temporal, which is a durable execution platform that it provides all of these things, especially to provide observability and monitoring for applications. That's a very interesting tool. So this course is to understand now this well-battle test state management application that what is the problem that RTKey actually solve, and to understand that, well, we need to know is what Redux and how can we create our own Redux. We're not gonna actually build that. We in fact gonna describe what it is doing, and that is, well, because especially if you need to manage states in your applications, the more inputs a particular state needs to react, or in other words, the more different state the more different states a particular state needs to be. In other words, if you have a button, so it can be on click or press or disable. So the more states or inputs that particular state needs to react, the more it makes sense to make that state updates maintainable and manageable. So we have now a particular way to do that, or a pattern to do that, which is following is the Flux architecture. Okay, so you have your actions, your dispatcher goes to a store, and then update the view, and this is this feedback loop. So in this case, with setting up a reducer requires a lot of ceremony, especially if you only want to add a new set of actions. You want to know handling is a new state to manage. So in there you need to create is the actions in a constant file, where here you're going to have much more control of all of the possible states, that all of the different possible state that state can be, and then you're going to create is another file which is the actions that is going to have is the type and the payload. Again, all of this is following is the Flux architecture pattern, and then you're going to have another file which is the reducer, where it's in here where you're going to define all of the logic that is going to take the state and the actions to generate a new bit of a state, right? So all of this process is requires a lot of ceremony, one, and second is not so friendly with TypeScript, all right? And not to mention that when you need to add some sort of middleware or some sort of functionality to that, all right, you actually have to Google a lot to do that. And when you need to handle is asynchronicity. So if a particular state needs to actually work not only with other models in your React applications, but also it needs to be updated based on some side effects or some data fetching or any other input and output events. Okay, so particularly data fetching, which is the most common thing that you're going to do in an application, it is important to say, how can we handle that? So now Redux or RTKey actually provide a very nice, convenient way to do that. And I think that's quite interesting. So to understand, so this is the problems that RTKey solve, right? So we don't have to actually create all of the ceremony for us, as well as provide a better TypeScript support. And also, we can easily add middlewares to that and work with asynchronicity, work with data fetchings to update our state properly. Not to mention that we can also work with other states as well. So for that, first, this course is layout. It's a very small course, okay? But I think it's gonna take me quite a little bit of time, especially to understand is the core concept that is solving. Something that we're gonna talk in today's video. So this course is, well, first we're gonna take a look at how can we create is our Redux, okay? And especially what Redux offer from us, and how can we work with different models, and also how can we now integrate now TypeScript to that, which is very, very, very convenient, and how it's actually generating type for us, which is lovely. And last but not least is like, how can we then is work with the data fetching, specifically with RTKey query. Okay, how to do data fetching to update the state properly. So first thing first, we'll look at the Redux toolkit, right? So create slides, create actions, and create reducers. So create slide is a convenient way to actually bypassing is the initial state, the name slides, as well as the reducer. We're going to get is the creation actions, the type actions, as well as the reducers and the state, right? So how did things work? Well, because behind the scenes is now using is the create actions, which is a built-in function from Redux, which is just a fancy way to say, hey, this create actions is just creating is the type object or the action object, right? Followed by the proper action type, as well as provide you the types of that object. And the action object is something that we mentioned before, which is the type and the payload. Okay, so this is quite easy to get it. The other is how can we or the other things that Create Live does is to use now create reducers. So in the create reducers, now we're gonna dive deep into the problems that not only React is trying to solve when it comes to state management, but other frameworks as well. Bear with me, stay with me. So create reducer, in this case, what it does is recognize that because creating this reducer requires a lot of boilerplates. Create Redux is just Create Redux or simplify this by providing also better TypeScript support and make the data or mutating your data in a JavaScript syntax like. Because at the end of the day, anytime we want to update our state, the Flux architecture says you need to create a new state out of that. And this is coming from the functional programmers when they say instead of actually us to assign variables and then mutate that, a lot of the time functional programmers, or the goal of functional programming, one of the goal of functional programmers is to try to identify when a bug will happen. So by applying some practice and patterns to avoid them. This is okay. Let's gonna make it more real, more tangible, shall we? So, because create reducer, especially when you want to update the data, it allows you to update that. It allows you to create this new state in a mutable like syntax. How that's possible is thanks to something called Immer. And Immer is this very compelling library, JavaScript library, that it say anytime you need to create is a new state, okay, we are going to now detect those states change for you. That's one. The other is that because anytime you need to create nested objects, or when you need to create new copies for nested objects, you have to do that on hand, so with bare hands. You have to do that per level. So only to modify is specific properties at those levels. So the idea of this is something from Immer, right? Immer. So the idea of this mm-hmm. 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 Exactly. React Copy, React Redux Toolkit, the official opinionated batteries included toolset for effective Redux. Um, Redux box, quick Redux, by to most of the time is Redux, Redux Immer, and many more. Lightweight yet configurable solution for implementing Undo Redo in Angular apps on top of NGRX and Immer, and many more. Mm-hmm. Okay. Strapi plugin upload. That's one of the reasons why it's important to understand what is the problem that this actually solves. And let's get into this. Okay. In Immer, German for always, Immer, it's a tiny packet that allows you to work with the immutable state in a more convenient way. So the problems that, as I mentioned before, what is the problem that they actually solve is that Immer will detect accidental mutations and throw errors. I will remove the need for typical boilerplate code that is needed when creating deep updates to immutable objects. Or in other words, anytime you need to create a new copy of that per level by hand, you have to do that for yourself, only to mutate a specific set of property at that level, and so on and so forth, and that kind of thing. But you need to copy the entire object at that level, update the property that you want to, and do the same for the next level, and so on and so on and so forth. So and when you're using now Immer, you don't need to learn a dedicated API or data structure to benefit from the paradigm, of immutable data structure. So quickly I'm going to describe this, okay, and then understand what this immutable data structure is. So Immer can be used in any context in which immutable data structure, the concept that we're going to talk about, needs to be used. So anytime you need immutable data structure, you can use Immer. The question is that, what is immutable data? Hold on. For example, in combination with React state, React, or Redux Reducer, or configuration management, interesting. It's actually giving you some of this use case, all right? So configuration management, React state, React or Redux reducers, immutable data structure allow for efficient change detection. Okay? Immutable data structure allow for efficient change detection. If the reference to an object didn't change, the object itself did not change. In addition, it makes cloning relatively cheap. Unchanged part of the data tree don't need to be copied and sharing memory with older version of the same state. So there are two things that actually it allows. It allows you to now it provides this change detection, okay, as well as cloning ability. So change detection in an efficient way, okay? If the reference to an object didn't change, the object itself did not change. And in addition, it makes cloning relatively cheap, because keep tracking of change in an object is something that can be CPU intense, especially if there is a lot of people or there is a lot of property that is being changed in this object. Okay, not to mention that because at the end of the day we want this to generate a new bit of a state, instead of mutating that, because that's the whole point of this, avoid mutation, especially for functional programmers. And the reason why we're looking at the Redux is for that, is like, instead of actually mutating the state, let's going to use this flux architecture where you have the actions, reducer, and the state, and then let's going to generate a new bit of a state for that. So because generating a new bit of a state or copying that, it's something that can be CPU and memory intense, especially if you want to do that regularly or as a common practice. So the idea here is to find a way of how you can actually do that. But we need to, that's going to keep describing here. It's going to keep talking, yeah. I'm going to keep looking at this and then understanding is what is immutability, sorry. So generally speaking, this benefit can be achieved by making sure you never change any property of an object. You never change any property of an object. But if you never change a property of an object, or if you only have an application with read-only state, that's not a very useful application. And in fact, you're gonna download it and then delete that. So generally speaking, the benefit can be achieved by making sure you never change any property of an object, array, or map, but by always creating an altered copy instead. In practice, this can result in code that is quite cumbersome to write, and it is easy to accidentally violate those constraints. And the whole point of this is applying this particular practice. This set of practice. Okay. Remember what we want after all, right? We wanted to generate is a new bit of a state, and because that required from the developer is a discipline, is a set of practice that it needs to do anytime you want to do this particular way, or a pattern, and you need to update your state. You don't mutate that because that leads to errors, okay? And that's why, for example, here functional programmers are taking this serious, and one of the things that functional programmer does is to try to predict when an error happens, and by following and applying some practice, you can prevent this. This is something that this is a couple of notes that I take yesterday that to me was quite interesting, according to Kyle Simpson, right? When he mentioned is exactly. So one of the things that functional programmer does is to try to predict where the bugs are gonna be and avoid them by using patterns where they can happen. So this particular patterns or practice to exactly. So these particular patterns or practice to avoid that a bug happen, okay, is one of the role of the functional programmers, and I think that's quite interesting, because most of the time my experience has been on the object-oriented programming, right? So where the whole idea of this is to, well, how can we now bundle the data and the functionality into one single package, or into one single bundle, okay, into an object. So instead of actually us to look at different files, we can have everything in just one single file. In the context of JavaScript, so by having now the data and then the functionality in one object, how can we make that in a way that is efficient? So for example, anytime you want to create a new object, how you can make the data and the functionality in the same bundle and don't repeat itself. So only create is data that is relevant, and the functionality, which is gonna remain the same, how you can actually is make that how can you share that functionality? So that's why we look, for example, the object.assign that allows us to say, hey, this function or this object that will contain all the functionality, all right? Let's say for a user, let's say you want to build as a game, and in that game you have now the users, which contains the name and the coins and the email, right? But let's say to the name and the coins, all right? And you have now the functionality that we're gonna be shared across all of these different users. So Bob, so Alice, Bob, John, Doe, wherever, okay? So the data is different, but the functionality is the same. So that's why we create an object that actually is wrapping the functionality here in one object, and then each one of these data portions, we now create a link. We provide an access to this instance. Okay, so that's what we are. That's what we use is now object.assign as a way to provide now that access from this portion of data from the users to that, and that actually worked quite well. But when we need to or the spec developers in JavaScript actually provide now is this new particularly syntax of how can we now is create our objects, okay, in one single step or in a small series of steps. So we don't have to create is a particular object that contains all the functionality per data, right? So they now say, hey, instead of you having to do that, let's going to provide now the new keyword where you are going to say, hey, this is the functionality that we want, or this is the function constructor where you're going to provide now all of the necessary data anytime you want to create that. And also this function constructor, which after all function is just a special type of objects which are callable, okay? And like objects, you can add property and remove that, modify its value. So that feature of adding property, it will be under the prototype. So the prototype here is part of the prototype change of now how they're gonna share is functionality across different pieces of data. So we have now the new keyword and how that things work behind the scenes when you're creating is your function, and that's quite interesting. That's actually is what you're gonna see in a lot of code bases out there, and because especially if you come from a Java environment or any other programming language, Python, you name it, this particular things or this inheritance, this way to provide now access to other objects, is quite weird. This prototype change is quite weird if you don't understand how the mechanism of the language. Perhaps I'm quite boring you right now at this point. It's like, why do you talk about all of this? Yeah, we know that, or you don't know, is what is this relevant for all of this, all right? So especially when you're creating is your class, or when you understand now how the JavaScript works, in now using is the new class or using the class keyword as a way to now create objects. I'm describing is, and I talk all of this because this is the way of how you can create applications, use an interface that are relevant for UI specialists or for anyone who needs where you need to provide this service to companies, or when a company hire you to actually build user interface. So this is the way of how we do the things back in the old days, and not that old, right? you have now is the object-oriented programming. So React actually at the beginning it say, all right, let's gonna use that. For example, React versions 16. They say, okay, let's gonna use that, or previous version of React 16. It's like, hey, let's gonna use this. But as they keep using that tool with that particular approach, especially because now the nature of JavaScript is not only providing interactivity to web pages, which is great, but also is to now call data from another service, right? Data fetching. So first thing first, we need to provide is interactivity to our UI components. The object-oriented programming is the way of how we did that, but now functional programmers that also started to get in here say that way of creating programs when you have the data and the functionality is quite interesting, solve a lot of the problems, but also create new ones. So for example, when you need to mutate the data, so if you have now if your building is a betting application, if you're building a betting application or an auction application, where let's say Red Sox and okay, where Red Sox exactly, where Red Sox Blue Rays. Interesting. Alex Cora. Mm-hmm. But for example, interesting. Yeah, but for example, Red Sox, right? Red Sox and Yankees, or Rays, okay, and Astros. So the whole point of this is if you have now betting applications, okay, when you have these teams, the Red Sox and Blue Jays or Yankees, right? Red Sox and Yankees, right? And a lot of people are betting for the result, okay? And you have an object that is capable to, of course, keep track of that. So you're going to mutate that object or that bets. So you're going to add a lot of these bets or even change all of these bets per user. So that when you're starting to do this kind of thing, you realize that mutating all of this is quite hard to keep track because you don't have any way of knowing that. You have to do that by hand. There is a lot of cognitive burden happening there, and also the data is gonna move around every place, right? So data is moving in any place. Exactly. So data is moving in any yeah. So values are portable, especially if you're passed that by reference, and they can be passed by your programs. So they can be passed by across the entire programs, okay, and also for third-party libraries. So what happened is that functional programmers with this ability to say, hey, we're trying to predict where a bug will happen, avoiding by using its patterns, and avoiding by using patterns where they can happen. So one of the patterns for that can happen is for us to say, well, this particular new pattern, when it comes to handle is a problem of data mutability, is to create a new state out of that. This new state will contain is the state change of the object is something that we want to do. And for that we need to talk about is immutability or mutability. So mutability here is something that we know, something that it changed, but the term immutability here in the context of software is not the same as the English language or the Spanish language, right? When you say, hey, these things won't change. What the reality is that if a program state won't change, so that's not a useful application. So the idea of this is to understand what immutability means in this context, pretty much like anthropologists actually say, hey, this particularly, so context is important. Context is important. So anthropologists will understand me in that regard. So context is important. So immutability here, it means that this data it's never gonna change. It means that we need to find a way that change that needed change needs to happen with intention. So we need to have a way of how those state change happen. We need to know how can we control change in our objects. How do we control mutations? And how do we control change in our objects? That's what is immutability here. In this concept, which is what we are actually describing here is talking about is data structure, immutable data structure. So when we talk about immutability in the context of software, it means that we need to find a way to needed change needs to happen with intention. In other words, how can we control mutations? So for that, we need to talk about is two main ways or two type of immutability here that we need to pay attention. One of them is assignment immutability, where this is when you use the const keyword, where this const keyword can be confusing and make a lot of people trip about it because a lot of the time you think that is value immutability, so whatever value it won't change. What the reality is that is the assignment that is immutable. Okay, it means that you can reassign these new properties. So that is a reason why, for example, and not only that, but also to prevent is this thing called the temporal depth sum, which is when you define is a variable and then when you assign a value to that. So the whole point is that to eliminate those kind of problems with const. And if we mention, right, if we now Okay. So if we mention that the whole point of this is to make that theme or with the assignment is that you define your cons, you define your assignment, and that is something that can be confusing, especially for new developers or any developers that comes from other backgrounds and then started to realize like, hey, what is the cons means? Oh, it means the assignment immutability. So according to Kyle Simpson, and perhaps I kind of, I'm agree as well with that. He has, of course, more experience than I do by actually building several applications and creating bugs in in multiple applications. Is the idea of that most of the time assignment immutability live in a particular context, and that context is small. So if you're going to build a functionality or some logic, so functional programmers or programmers says keep that into a small containable area. All right, that's one. So make it visible on that particular is on the viewport. Okay, and not only that, because at the end of the day, functional programmers says we don't want to assign things. We don't want to create things. The less assignment that you have, the better off will be, because one of the purpose of that is to create a new state out of that. Okay, so it means that the purpose of cons in assignment immutability is something that is not that helpful as we might think. But that thing exists. Okay, we have now immutability. And as we mentioned, immutability is how can we control mutations? Is that needed change, okay? How can we make sure that needed change needs to happen with intention? Okay, or needs to occur with intent. So it shouldn't be accidentally, so happening outside of our awareness. Okay, happening outside of our awareness, happening at different times and creating race conditions. No. We need to have this certainty when we creating, when we need to apply change to that. That's what immutability means, right? So we look at these the two type of immutability that we need to pay attention. The assignment, we describe it straight off, how you can do that in JavaScript. And also how most of the time when we work, when we are building our applications, we don't care too much about the assignment. In fact, we care more about is that the data is going to change, especially since values are portable. Okay, since values are portable, so and especially if you pass that by reference, so they can be passed by programs and even all the third-party data. So they can now pass through all of this, right? So a value immutability, which is a more interesting and useful case, is that the problem is not of mutating data when we need. Okay, the problem of mutating data is we need to be careful to prevent side effects. And side effects are unintended things that can happen in our programs, and that is, for example, input and output, or mutating a data structure, or global objects, just to mention a few of them, right? And anytime we pass down data, ask yourself, this is quite interesting. And anytime you pass down data, ask yourself, how do I know that passing this data won't change that? So how, no, how do I know that passing down that data, it won't change in ways that it produces a bug? Okay. How do I know that data isn't gonna change in a way that is gonna produce a bug? So remember that after all, something that I previously described, remember that after all, functional programmers, one of the things that functional programmer does is to try to predict, and again, this is a mindset, okay? This is a particular mindset, and I really love about this, to take time to actually pondering in these concepts, because pretty much like object programming is all about, this is a mental model to how to create applications. You have a mental model to do things. The functional programmer now have a mental model to actually do things as well. So when they're creating their application, one of the things of that is to one of the thing of that is to try to prevent where a bug will happen, avoiding by applying its necessary or by using its patterns to prevent them. Or by using patterns where they can happen. So anytime you're going to pass down data, ask yourself, how I'm sure, or how do I know, okay? How do I know that passing that data, okay? So how do I know that data? Yeah, how do I know that that data isn't gonna change in a way that create a bug or produce a bug? So one of the way to do that, okay, especially if you want to create now applications with that mindset, is like, hey, how do I know that data that I pass, especially as reference, isn't gonna change in a way that produce a bug? Interesting. And for that, we have now a particular pattern. So one of those patterns is to mark read only. So you're now explicitly using annotation here in the language. You say object.free, say this is an annotation to say that the data that I'm passing down there is read only. So this is one of the patterns that you can apply when you are describing this. This is one of the disciplines or this practice that you can apply when you're writing your application. Okay, makes sense. All right. So again, this is useful when you want is to pass now immutable data. Hey, this data that I'm gonna pass to you cannot be changed. All right, and I'm gonna make sure that by passing is just a object of read only, using the object of freeze. So this is important to communicate that with this annotation. So we have now value immutability when you want to pass now read only data, okay, and also when you are going to receive that data as well, because only read only database practice is like all of this. This data, this read only best practice is to say, Interesting. Okay. So all of this read-only database practice is just to cover is one specific theme, which is value immutability. Okay. especially with read-only data. Okay, so this is useful for configurations most of the time. Interesting. So when you're gonna pass down this data, okay, and the other is that, well, in your functions, you must always assume that that data that you're getting is read-only, right? So you create now a copy of that, and then you mutate that, so you're gonna pass down to whatever other things it needs to. So by having this particular pattern approach of how you can now is handle immutability in the language, especially when you want to create applications, and the immutability here is to understand what are the needed change, so immutability here, it is that needed change, is that needed change, okay, needed change in an object, change with intent. So they can happen without awareness, randomly, race condition, none of that. So how can we actually have control of mutable data? And that is, well, we look at the assignment in the two type of assignment. You have the two type of immutability that we must pay attention, which is assignment. We also look at the trade-off of that, as well as the value immutability, which is one of the core of this, and how that lead us, thanks to the functional programmers, to say, hey, you know what? Because our job is to try to predict when an error will happen, avoid it by applying patterns that they can happen. Okay. Yep, it's pretty much like that. So by using patterns where they can happen, okay, and one of the patterns is that if you need to pass this value immutable, put some annotation to that. So tell the language, hey, observer object.freeze is that this object they're gonna pass down is a read-only. This is when you're writing. This is when you're passing data to functions, and when you're writing your function, it's like, okay, I'm going to assume that whatever we're receiving, okay, treat that data as a read-only. So far so good, right? Because we haven't talked about this immutable data structure. We only talk about is the immutability, which is the core of this. So now when it's time to actually talk about this immutable data structure,
But again, that's still, so read-only data structures are data structures that never need to be mutated. That's key. A read-only data structure is a data structure that never needs to be mutated ever again. You might create it and do some mutation in its creation process, but at some point you freeze it, you say it's done, it's final, it's complete, and then you move on. You use that in that final value form for the rest of the program. That actually is, there's a lot of those. There's a lot of times when we create a config object that we're going to pass in to an AJAX call or something like that. That's an object that isn't going to change, or at least it shouldn't. Otherwise, we're probably going to have bugs that we don't expect. So that's an example when we pass in an object, when you pass in a configuration array or something like that. You even take a JSON response from an API. That's a value that's done. It's come back from the database. It's come back from the API. It's done. It ought to be marked as read-only, because there's no reason for us to be mucking with that in some way that's going to end up creating a misexpectation and therefore a bug somewhere else in the code. Those are all data structures that don't need to be mutated. But that certainly can't be all of our data structures.
Exactly.
We certainly can't imagine a program that would do anything useful if all of our data structures were in this read-only state. Some of them, sure, but all of them in a read-only state would mean a program that was fixed and did nothing, and we could just delete it and move on. So when I take that process order function and I pass in an order to it, you'll notice here that I'm trying to change it because I'm doing something that makes sense only for the database. I'm not even thinking about what somebody might have done with that order object after having called me. I'm just trying to make sure there's a particular flag on it before I try to save it to the database. You see the mutation there? The mutation that occurs by reference is, by definition, a side effect. We have an impure function. Of course, we have an impure function because of the database call, but we have another impurity which can create huge bugs in our program. So just because somebody may or may not remember to pass in object.freeze, I have an even more important point to make about this idea of value mutability, which is if somebody passes you a value that is in its identity mutable, something like an array or an object, then it is incumbent upon you, the author of the function. You don't know all of the call sites for this function. You don't know whether they're going to pass object.freeze or not. The best thing for you to do is to always assume that it's a read-only data structure. Always assume that you're not allowed to mutate it. Don't assume that because you mutate it and you don't see an error at that point, that nobody else is going to try to pass in an object.freeze data structure, in which case you would have a fatal failure. Always assume that you're not allowed to do line 3, you're not allowed to mutate it. So what do? We need to add a status field to it before we save it to the database. The answer is, you make a copy of the object. You make a copy of the object, which is what I'm doing on line 2, and that copy, I'm simply using the ... operator, that's object spread. You make a copy of that object, and then you can mutate it internally all that you want, because you're not having a side effect on the outside program. You should always, always assume that it's a read-only data structure, no matter what. So there's two sides of this issue, and don't lose track of them. One side of the issue is that when you call a function and you're going to pass in a data structure, do your reader the benefit of annotating it that you want it to not be changed. Use something like object.freeze. And secondly, and maybe even more importantly, when you write a function that receives data structures, treat it as if it's read-only no matter what. Make a copy of it, make your changes to your local copy. That's how we deal effectively with value mutability. But again, that still only tells us something about data structures that never need to change. What do we do with data structures?
Mm-hmm. 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 Yes.
That do need to change.
Exactly.
Well, you can't treat all data structures as immutable data structures, as read-only data structures.
Exactly. So what happened to data that needs to change? Yeah, what happens to data that needs to change?
Well, you can't treat all data structures as immutable data structures, as read-only data structures.
Mm-hmm. So you can treat all of your data as immutable, as read-only. Some of them needs to change.
Some of them are going to have to be mutable. And here's the real counterintuitive thing. When you have the need for a mutable data structure, that is one that is not read-only, what you actually need is an immutable data structure. Let me say that again because it's really strange. When you need a mutable data structure, what you actually need is an immutable data structure. So what am I talking about here? What do I mean by that? A mutable data structure, what you actually need is an immutable data structure. So what am I talking about here? What do I mean by that? An immutable data structure is one that allows not no mutation, but rather structured mutation. Structured, controlled, intentional mutation, as opposed to just willy-nilly make an assignment statement and create a side effect somewhere. It's the next level from a read-only. You should start by asking, is this ever going to need to mutate in any way, shape, or form? If so, then I don't use a read-only. I need to do something immutable. But if it never needs to change, then just stick with the plain, simple read-only data structure. We only step up to this immutable data structure if it needs to mutate. So what exactly is an immutable data structure? It is a representation of the data structures that we are used to dealing with. We're used to dealing with data structures like arrays, where we can access things at index positions. We're used to dealing with things like objects, where we can access things at named property positions. It's things like that. It's data structures like that. But where you don't have access to the actual underlying data structure, what you have only is an API to access it. And the API creates a layer of control that prevents unexpected changes to the data structure. Specifically, what an immutable data structure says is unless you switch it into a special mode that allows this. So by default, it's not. If you switch it into a special mode, you can literally go in and muck with it if you have like a performance problem that you need to deal with. But in the general state, an immutable data structure says, essentially, you cannot change the data structure. You can only create a new data structure with the change having been applied. Similar to what we did a couple of slides ago when I made a copy to the thing and then I added the status field to it. It's similar to that concept. It says, listen, I need to add something to it, and the response from the API is, okay, but here's a new data structure with the change applied. I'm not going to let you modify the previous one. And the reason I'm not going to let you modify the previous one is that somebody else in the program might be relying upon the previous state of that object. They have to opt in to saying, I want your version of the object. You don't get to decide, process order, that you're going to affect something at a distance somewhere else in the app. You could return the new order, the processed order with the status field, and allow the caller of your function to decide what they want to do with that information. But you don't get to mutate it from afar. That's what I mean by saying that an immutable data structure creates a control mechanism. It creates a controlled, intentional way for the mutation to occur. And by default, it simply says, let's make a whole new object, a whole new array, a whole new list, a whole new object, a whole new map, whatever the data structure is, make a whole new one of those with the change having been applied. Now, the question becomes, how could that possibly be performant? How could it possibly be performant for me to make a whole new copy of this array or a whole new copy of this object every single time I need to make a change? Because the kinds of objects and arrays that we're talking about that need to be mutated probably need to be mutated a lot. Not once or twice, not 3 or 10 times, but like thousands of times a second. So the ante is high for if I'm going to change this thing over and over and over and over again so often, and I'm creating all these new ones and throwing all the old ones away, at worst, at best, I just have a bunch of garbage collection, but at worst, you consider all the CPU churn of making all those copies over and over again. And this is where the real power of an immutable data structure comes in. Because the way immutable data structures are...
Churn. Oh, churn. A machine for making butter by shaking milk or cream. Oh, to churn. Oh, okay, to churn. Turn. To shake. Into the term. That's British. Yeah. To churn. To shake.
Design, making all those copies over and over again. And this is where the real power of an immutable data structure comes in. Because the way immutable data structures are designed is designed specifically with this optimization in mind. In theory, in functional programming, we just say, no, you don't make a new thing, you don't make a change to a thing, you make a new thing with the change applied. But in practice, that means real cost, like garbage collection and CPU. And so it is the job of an immutable data structure to mitigate that real practical cost so that we get closer back to the theoretical benefit of what an immutable data structure is. So if you use an immutable data structure, what it's actually going to do is not create a whole new copy of the object when you try to change a property, but rather make a new object with the new information in it and internally have a pointer back to the previous one. It's actually a little bit like a Git repo, where every time you've committed something, you're just storing a diff compared to what it was before. An immutable data structure is essentially conceptually like a Git data structure, where each new object in the chain that you've created is just a diff on the previous object. It stores internally that there's now a new property or that a property's been changed or something like that. And so you're not paying nearly as much of the performance penalty CPU, and you're not paying the garbage collection penalty. In the general sense, there's certainly corner cases here, and it's why immutable data structures can allow you to opt in, for a time period. You can sort of crack it open, make some changes, and then lock it back together. Those things have to exist because sometimes we have performance bottlenecks that we need to deal with. But in the general sense, we want to just use the data structure in that conceptual way and allow it to abstract away those performance optimizations for us. So, how do we get immutable data structures? We do not, at the present time, have immutable data structures natively in JavaScript. There have been a couple of rumblings from some people on TC39 that maybe someday that will happen. But you need to understand that when somebody says, oh yeah, somebody on TC39 has talked about maybe it happening, that means that we might get it a decade from now. That's not like, oh, it's going to happen in a few weeks or a few months. The timelines that we're talking about here are, oh, it's been talked about for the last 5 years, and now there's like a first proposal, and then 4 years later they vet it, and now it's finally landing. So we're not talking about this sort of stuff landing natively in JavaScript anytime soon. But it's at least encouraging that some conversation has started about it. Some people in that realm have started to say, maybe this would be useful for JavaScript to have built in natively. And there would be a huge benefit to the language being able to highly optimize these sorts of things that we're talking about. In the interim, in any place where you have a data structure and it is important for you to manage the mutations to that data structure, you're going to need a library that provides you an immutable data structure. And there are a couple of major ones out there that you will hear about. Probably the most common of those is called Immutable.js. It comes from the folks at Facebook. So if you want to check out Immutable.js, they've got a bunch of great documentation. It has a huge community around it. It's a great library. There's another one out there that seems to be preferred by people from particular sects of the functional programming community, especially those that kind of come from like the Clojure and that sort of side of our programming community. That's called Mori, M-O-R-I. ClojureScript, which is the JavaScript subset of
ClojureScript, which is a JavaScript subset of
Clojure, the language, has immutable data structures in it, and what they did was extract those immutable data structures into a library, and they released it called Mori. Has a different take on the way that it works and what the API looks like, but same general end goal, which is give me structured mutation on my data structures. So here's an example. I created an immutable list of a couple of things. Now, it doesn't really matter whether those things like textbook and supplies are strings or objects or arrays. From the level of the data structure, the outside, all we're saying is the presence of those in this list is what is immutable. If those things were objects, then they would still be regular old mutable objects. So if you want to have deep immutability, you want to prevent one of those sub-objects, then you're going to need to use immutable data structures at every level. But I left it sort of deliberately general here. We don't know what textbook, supplies, and calculator are. But at this point, that's not our concern. They could be immutable JS objects or maps or something like that, or they might just be regular old plain objects or strings or numbers or who knows whatever. But the point is line 6, when I say .push on an immutable data structure, an immutable list, it's not going to actually modify that list the way it would have with a normal array. Instead, we're going to get back a whole new object. That's called updated items. And that new updated items object has all the same stuff as the previous one, plus the new object having been added. And that's why items.size is still 2. It didn't get changed in any way, shape, or form. It is an immutable data structure. And internally, they've taken care of the optimization to have the pointer to be where it needs to be. So let's review what we've talked about here. We started by talking about the idea of assignment mutability. Generally speaking, we're talking about the const keyword and whether or not it's going to provide the benefit. Usually, functional programmers try to minimize the amount of assignments anyway, so it probably shouldn't be the case that you have very many of those declarations. But for the ones that you do have, you're generally going to be doing them inside of small blocks, and the const keyword is not going to provide much benefit for you. So maybe it's more appropriate to use a var or a let in those places, just so that you don't trip up the reader of your code. My rule is not that I don't use the const keyword, but that I use the const keyword only for things that are already, by their very nature, unchangeable, like numbers and strings. So I'm fine if you say const base price equals 6, but don't ever, please, at least in my opinion, say const ARR equals and then use an array, because that is inviting the reader to get tripped up. The real point that we should be focusing on is the value immutability question, and we have two different ways, actually 3 ways of thinking about that problem. One way is, at the call site, when we're going to pass in one of those data structures, we should annotate it with something like object.freeze to say to the reader, don't worry about it, it can't be changed. And if you need to do sort of a recursive object.freeze thing, make yourself a little helper and just use that helper everywhere. You know, use the little helper called read-only that you pass in an object and it traverses an object and makes it deeply read-only. That's great. Whatever you need to do to annotate to the reader, they don't need to worry about that thing changing. Secondly, when you receive a data structure, no matter what, assume that it should be read-only. And lastly, if you need to actually track changes to data structures, that's what you should be doing with an immutable data structure.
So
but again, that still only tells, but here's a new data structure to do with that information, but you don't get to mutate it from a. Now the question becomes, how could that possibly be performant? How could it possibly be performant for me to make a whole new copy of this array or a whole new copy of this object every single time I need to make a change? Because the kinds of objects and arrays that we're talking about that need to be mutated probably need to be mutated a lot. Not once or twice, not 3 or 10 times, but like thousands of times a second. So the ante is high for if I'm going to change this thing over and over and over and over again so often, and I'm creating all these new ones and throwing all the old ones away, at worst, I mean at best, I just have a bunch of garbage collection, but at worst you consider all the CPU churn of making all those copies over and over again.
The CPU churn.
And this is where the real power of an immutable data structure comes in. Because the way immutable data structures are designed is designed specifically with this optimization in mind. In theory, in functional programming, we just say, no, you don't make a new thing, you don't make a change to a thing, you make a new thing with the change applied. But in practice, that means real cost, like garbage collection and CPU. And so it is the job of an immutable data structure to mitigate that real practical cost so that we get closer back to the theoretical benefit of what an immutable data structure is.
Mm-hmm.
So if you use an immutable data structure, what it's actually going to do is not create a whole new copy of the object when you try to change a property, but rather make a new object with the new information in it and internally have a pointer back to the previous one. It's actually a little bit like a Git repo, where every time you've committed something, you're just storing a diff compared to what it was before. An immutable data structure is essentially conceptually like a Git data structure, where each new object in the chain that you've created is just a diff on the previous object. It stores internally that there's now a new property or that a property's been changed or something like that. And so you're not paying nearly as much of the performance penalty CPU, and you're not paying the garbage collection penalty. In the general sense, there's certainly corner cases here, and it's why immutable data structures can allow you to opt in, for a time period, you can sort of crack it open, make some changes, and then lock it back together. Those things have to exist because sometimes we have performance bottlenecks that we need to deal with. But in the general sense, we want to just use the data structure in that conceptual way and allow it to abstract away those performance optimizations for us. So, how do we get immutable data structures? We do not, at the present time, have immutable data structures natively in JavaScript. There have been a couple of rumblings from some people on TC39 that...
But one of the things that you mentioned here of immutable data structure is that by design, the problem or the problem that immutable data structures wants to solve is the ability to control, the ability to keep track of state, the ability to keep track, change, apply to your data. Okay, that's the whole problem that immutable data structures wants to solve. All right, the problem that immutable data structure wants to solve is the ability to keep track of change, apply to your data. Since it is something we don't have right now. Exactly, we don't have right now. Okay. The problem that immutable data structure wants to solve is the ability to keep track of change applied to your data, since it's something we don't have right now. Okay. Yes, since it's something that we don't have right now. So by wrapping an object with an API, okay, which is something that Immer is not using an API for that. When using Immer, you don't need to learn dedicating API or data structure to benefit from the benefit. With Immer, you will use plain JavaScript data structure, and use the well-known mutable JavaScript API, but safely. Shallow clone the array, and how Immer works. And the basic idea is that Immer is produce the base state from a slice, shallow clone the array. Okay, shallow clone the array, mutate that. All right, and then add this to that. Since next state was freely cloned, using push is a safe here, but doing the same thing at an arbitrary time in the future will violate the immutability principle and introduce a bug. With Immer, you say, give me the base state and a draft that I'm going to now use it to mutate this object, and then I'm going to generate is the next state for you. Because the whole point of this is to make your data change, so the whole point of this the whole point of immutability is needed change with intent. So we know what's going on there. We know how we control what happened here. So wrapping an object with an API that expose some methods that internally can update the data with the new state. Okay, generate a new state. Okay, update the data with the new data. Okay, update the data with new data, generate a new state. Okay, generate a new state and do that in a performant way. So the idea, but again, you're explaining is now what immutability JS over is working here. So the idea behind is pretty much like Git. When you add div to your when you add div to it. So Immer doesn't require a new API to learn like Immer. So Immer doesn't require a new API to learn, and by having is a draft object where you can introduce your change. Okay. Yeah, so Immer doesn't require a new API to learn, and by having a draft object where you can introduce your change, Immer, after that is done, it will apply the changes. So it will generate. So after Immer, after apply those change to the draft, you can say more shortly. So Immer, after that is done, it will generate a new state, a new updated state, or a new state. That'll be all for this video. Take care. Bye bye.